All right, it's about 10 o'clock, so I think we're going to get started. We might have a few more come in and join us, but well, let me start by saying thanks to everybody who is attending. We're going to have a few guests that'll roll in here in a few minutes, and I'll be admitting them in from the waiting room as we go through it. But either way, this is the long coffee break, or for some of my friends that are joining us, the long morning beverage break, if coffee is not your thing. Thanks for joining us. And today we're going to be talking about HVAC noise control, about adding value and reducing project risk through noise control and vibration control as well. Today with us, we've got Hvac. He's a regional sales manager for Vibroacoustics. That'll be doing all the heavy lifting, talking about the system and about some concerns that you might have. Just so that everybody knows, we're on a recorded line, and I'm going to go ahead and mute everybody at this point. If you do have a question, please raise your hand. Better yet, you can type into the chat, or at the end of the meeting, I'll take everybody off mute and we can have a conversation then. Also, if you're interested in talking about project specifics to a project that you're working on, we do have time afterwards in which we'd love to talk with you, so you can hang on after that. And also to mention, this is a weekly, semi-weekly service that we're offering. So you'll see at the end of this presentation a humidification that we're going to be doing for next week, and we'll have future ones. So I invite you to attend those as well. But at this point, I'll let you take this over, Hvac, and we'll go from there.
Perfect. Thanks, Jeff. Good morning, everybody. Thanks for your time. I will be talking about HVAC noise control. So to start with, we all see some common problems in HVAC noise control side. The number one problem I would like to talk about is the pressure drop. And we normally want to define that by making a difference in the ideal pressure drop. We call it a catalog pressure drop versus the actual operating condition one. So based on the ASTM E477 testing and ASHRAE guidelines, the suggestion is to leave at least 5 diameters of straight duct on the silencer inlet and 10 diameters of the straight duct at the silencer outlet. But practically, we never seen that before based on all the different projects. So always consider the system effect pressure drop in the submittals. And to explain that, I would like to bring this example to everybody here. So for example, let's say this is a straight silencer right here, right after this elbow, and there is a duct here and then duct going upwards. So this straight silencer is inlet is an elbow and outlet is an elbow. If we select this silencer based on the performance we need from the catalog, and we see the pressure drop is 0.15 inches at 1,000 feet per minute velocity, but then that looks everything is good, meeting the performance, and pressure drop based on ASHRAE guidelines is below the maximum level. But when we look into the condition at the inlet and outlet is an elbow, and putting that into the consideration, the pressure drop comes out to be 0.78 inches at the same velocity. So that's a lot higher than what's shown on the catalog. It's not only the wrong solution, but also wrong location for the silencer. The solution in this particular case will be an elbow silencer, which will have a better performance and a better pressure drop. If we put an elbow silencer right here, the pressure drop will be 0.24 inches with system effect. And the way we vibroacoustics show that when we provide the silencer schedule for any project, we show these two pressure drop. One, we call it idle pressure drop, and the other, we call it the maximum pressure drop with system effect. So we always show two pressure drops here. And there's a note on the bottom that says silencer must have a HTL casing equivalent to 12 gauge to control the breakout noise issue. And that actually brings to the common problem number 2, which is the breakout noise issue. To explain that, let's look into this case. This is the air handling unit, and the duct is coming out and branching out in both direction. Occupied space is right here. To look into the noise, to to take consider of the noise issue, somebody will put straight silencer in every single branch and think the noise will be taken care of. There will be no issue. But the problem in this particular case will be the issue of breakout noise. So the noise will be actually breaking out of this duct itself and going into this occupied space. Again, the correct solution for this case will be a T-shaped silencer that will not only take care of the airborne noise, but also take care of the breakout noise. And it's actually pressure drop in this particular case with the T silencer solution is 0.2 inches with system effects. And this also will be a cheaper option as compared to 3 straight silencers. The breakout is the most common noise problem in HVAC system. Reason for that is the lightweight room construction. The air handling unit is located right above the occupied space, higher sound power data of the equipment, and the occupied space near the mechanical rooms. To deal with the breakout noise issue, a calculation is always needed. And the reason for that is we need to find out what kind of casing is needed. We call it a HTL casing. That's a higher transmission loss casing. And based on the calculation, we'll find out what kind of thickness will be needed. For example, the standard casing is 22 gauge, but after doing the calculation, if there is a breakout noise issue, it can go to 14 gauge or even 10 gauge. It is actually nearly impossible to design a breakout situation with a catalog approach because no one can do a calculation from the catalog approach. It also gives a, a message that the application of the product is more important than the product itself, the location, and what are we trying to achieve, what kind of NC criteria for indoor HVAC systems, and a DBA criteria for the outdoor or environmental noise issues. We vibroacoustics, the way we do look into the noise control solution, we follow an integrated system approach. And what does that mean is we make a combination of acoustics and system analysis. So we look into the ASHRAE guidelines, or with the help of you guys, we will know what kind of NC criteria is needed. Is there a breakout noise issue? What are the noise paths based on the location of the equipment? That's on the acoustic sides. But then on the system side, you guys will also advise us that make sure we will not exceed the system effect pressure drop by this level. We look into that. What are the system effects? Like what is the inlet and outlet conditions? How much room is there to work with? So based on all that condition, we propose a solution that will not only work, but it will also fit based on the ductwork drawings. We do have different kinds of solution. We have silencer, barrier, acoustical louver, plenums, acoustical curbs as well. We do have different types of silencer based on the application of the project. Like we have dissipative and no media. And then we also, for hospital application, we have film line solutions, film line silencers. In terms of configuration, as I showed you, we do straight, elbow, T, Z shape, all the custom shape based on the duct itself. These are few examples of the transitional generator silencer. This is basically when we look into the generator application and the generator room. This is one of the good example where the mechanical engineer actually wants to propose a solution, but there is very less space in this particular case. So what we look into it, we did the analysis, and based on that, we find out we will utilize the transitional duct right after the generator and convert that into a transitional duct silencer. So in this case, we achieve, I guess, 15 to 20 dB noise reduction at the property line. And the owner was really happy because they do not have to move the generator location. Otherwise, they have no other option. If we do not come up with this kind of custom solution, they have to relocate the generator itself. The other solution we do have is the noise control vibration isolation curb here. This is really a custom solution, especially when the air handling or the rooftop equipment is basically located on top of the equipment itself. On top of the occupied space. So we designed this vibration isolation curb, which can be of 26 inches to 36 inches height. Based on the location of the project, we also do design seismic or wind load rated curbs. And then there will be a supply and a return silencer in it. And then there will be acoustical barrier panel. Of course, this is not the solution for every single rooftop unit, but based on the project requirement, we have done a few of these as well. Every year we do that, and long had a good success working out with the mechanical engineers. Let's say, for example, if it's a hospital application, there are 5 to 6 rooftop units, and 2 of those are on top of the emergency rooms. So we will look into that. We'll look into the what kind of NC criteria is needed. In that particular case, it will be NC 25 to NC 30. We design the solution, and we guarantee that by providing PE stamp acoustical calculation, PE stamp pressure drop calculation, and PE stamp seismic and wind load calculation. And this solution works well um, in all those projects because we provide an end result guarantee. If there is any noise issue down the road, we say vibroacoustics will take care of that, uh, of the NC criteria, and we provide PE stamp calculation for everything. Uh, Based on these few solutions, we look into every single project. So basically, we provide lane service. We call it a lane service that's actually providing acoustical analysis, uh, and we provide these kind of schedules as I showed you. These types of silencer schedule or other noise control solution schedule. This is a free of service lane service. All we need from your side will be just 2 things. It's sound power data of the equipment itself and the ductwork drawing. And we do understand that basically depending on what stage of the project you guys are, the ductwork drawings are not finished. So we work with you. We can start a lane with some rough ductwork drawings at a 30 or 50% drawings. And then once you guys finalize your ductwork, we can finalize our solution as well. So just the sound power data of the equipment and the ductwork drawing. The number 3 can be the NC criteria, but if we guys are not clear on that, we can always follow ASHRAE guidelines. So based on these 2 and 3 things, we can start a lane, look into it. We do the acoustical analysis and provide you a noise risk assessment report. That report basically say if there is any solution needed to make sure the NC criteria has met or not. That's it from my side. If you guys have any question, please let me know. And Long is also hosting their next session on February 25th.
Yes, thank you so much for that. And yes, join us next week. We're actually going to move our scheduled meetings to 10:30 rather than 10 o'clock to avoid another internal conflict. But we'll be sending out a separate email on that. And I don't have any questions yet, but if you do have them, you're more than happy to unmute or you can enter them into the chat. But Vivek, a few things that I actually am asked many times is
Sure.
the system pressure drop. That is a very important part of the component, and to get it with system effect. Is there any way to do that manually, or is it always best done by contacting someone like yourself and having a supplier, a manufacturer, actually provide that pressure drop with system effect?
That's a very good question, Jeff. So yeah, there is actually no catalog approach to actually calculate the system effect pressure drop. The best scenario is to reach out to you guys, and you can forward that project to us, and me and my team, like been on this call, can look into it and let you guys know what's the system effect pressure drop is. The option 2 will be we do have a software, online software. We call it a VA design. If anyone can interested in that, we can provide you login, username, and password. And that actually the same software my team is using it. In that, you will put the inlet condition and the outlet condition, and the software will generate a exactly similar schedule like this and show you both pressure drops.
Excellent. Now, sometimes the engineers will have acousticians that are on the project as well. And I know we don't take the place of an acoustician, but how do we
That's right.
work with an acoustician?
Another good question. So in the case where there's an acoustical consultant is involved, we do not do any acoustical calculation, but what we work is with them as a team. Um, 100% of the time, the acoustical consultant will provide an acoustical consultant report. By looking into that, we follow their guidelines and they let us know what kind of performance they need. And we select our product based on that performance requirement. Plus, we also look into the system effect pressure drop, because the one thing the acoustical consultant do not look into is the system effect pressure drop. They think it's the mechanical engineer side. They will look into that. So we make a combination of the performance requirement from the acoustical consultant plus the pressure drop requirement from the mechanical engineer, and then propose a solution. But in that particular case, we do not do any analysis. We just follow the guidelines from the acoustical consultant.
Very good. We had a question come in from Drew, and he asked, what is the typical pressure drop for most duct silencers?
Good question, Drew. So to answer that, it should not exceed with system effect more than 0.25 inches. But then again, it depends what kind of application we are talking about. I just told you if it's a rooftop unit or an air handling unit. In terms of generator examples, as I showed you that silencer, it should not exceed more than 0.1 inches.
And Drew, what I would suggest is if you are doing static pressure calculations and you want to include something for silencers, the 210s, 0.25 inches for each path is probably appropriate. So if you have them on return and you have them on supply, you'd have to accommodate for both of those, of course.
Right.
Now, the one thing that we do want to, and it's a very fine way of trying to design this, is you've got certain duct sizes you want to meet. You've only got so much room within the building in order to apply these into or lay them into your designs. And the more static pressure you put back onto the source, typically the louder it gets because you've got higher pressures that you have to overcome. So it's a very fine process that you have to go through to make sure that you've accounted for that. So if you do want to account for that in the beginning, a 1/4 of an inch per sound attenuator is probably a good bet. And if you've got some very extreme circumstances, some high duct velocities, some very low sound calculations, we had an NC of 5, if you can believe it, 5 on a project we worked up on at USU with actually Van Borem and Frank with Spencer Howe. And at that point, it's so quiet that you can almost hear the blood rushing through the capillaries in your ears. So it's discomforting. But those required 15 and 17-foot sound attenuators that had higher than a pressure drop of 0.25. So and again, there are extreme situations where we'll be outside that, but for normal HVAC, I would agree with the 0.25. Again, type in any question or you can unmute yourself if you'd like. But the last question I have is, many engineers, I think in our area, kind of have an impression that sound attenuators are a band-aid, are a problem of their own right, and the pressure drop is part of that. Do you see that from other markets, and how would you respond to that in thinking that that the engineer may have done something wrong if there's a sound attenuator in their design?
It's yeah, that can be the case, Jeff, and it actually no one will know until everything is installed, right? We do actually go into those situations a few times when somebody else actually selected something from the catalog. They think it's good to go, and when the contractor installed that will be actually the worst situation. Or sometimes they are taken out, right, from the design. And then we actually had one project in 2019 where we work on that, and the owner has to pay 3 times literally to do exactly the same thing what the mechanical engineer and we proposed, because then they have to take everything apart, put the silencer in, and then put the ductwork back again. So it's difficult situation. It's always good if we look into it upfront, and it can be sometimes there is no need to do anything, right? But it's based on that free lane service we provide and long provide, we can just double check that and let your mechanical engineers know that, what, there's nothing to be required in this particular case. You're good to go.
Yeah, and I think it's an important point to bring up that a good design from an HVAC standpoint encompasses everything from to the comfort of the individual, to the comfort in the space itself. And we spend a lot of time going over loads and looking at shading coefficient on glazing, and then trying to get just the right diffuser so that we've got the right amount of throw and that we've got thermally distributed air throughout the entire space. And there are some rules of thumb that are used with NC of a VAV box or a particular diffuser, but a lot of times I see engineers defaulting to, oh, I've used line ductwork for the first 20 feet and I've never had a problem. Well, I think that approach doesn't mitigate the risk that we've been talking about today. The
That's right.
ability to actually design that, to go through a process like vibroacoustics has, gives you that assurity. And I actually see it the other way around. When I see a design that have a sound attenuator in there, I really feel that the engineer has gone that extra mile in order to provide the proper space conditioning, because that is just another technique, another tool that you have in order to assure that you've got the right NC in the space. And completely agree. Trying to fix those problems afterwards can be a ton of time, a ton of expense, and not just trying to install, a sound attenuator into a hard ceiling and ripping all of that out, but the amount of time that it would take a designer, which they haven't accounted for. Best to
Right.
do it up front. And just to put a capstone onto the lay-in service, really all we need, you can send it to me or any of your long representatives, is the source, what is making the noise. Now, that could be an outdoor condensing unit. That could be a fan within a unit. It could just be a crosstalk silencer, so someone on the other side of a wall. The path is critical, which is typically where we apply these, which would a lot of times be duct work, but could also be barrier walls if you're dealing with an outdoor chiller, or some treatment of the ceiling itself if we're talking about breakout noise. And then the recipient, what is going on in the space. NC level is helpful, but also talking a little bit about the space. A gym is much more reverberant than a lay-in ceiling office space. So if you can send us those three details and maybe an elaboration on those, that allows us enough to try and lay these services into your system and to tell you whether you do need sound attenuation or whether you might have a situation where you don't need that. So.
Right.
Well, at this point, if there's no other further questions, we'll close the meeting. We'll stay on for just a few more minutes. I'm going to stop recording. And if you do have a particular question on your project you want to get into, we're happy to talk about it. But hopefully we'll see you next week for a conversation about humidification. And again, thank you for attending today.
Thanks, everybody.